I'm Martez Killins, and I'm a solution engineer with Replicated, where I work with our customers as they kind of evaluate the Replicated platform and kind of walk through their journey as they come onto the Replicated platform. So today, we're going to talk about self-contained on-prem and private cloud installations with Replicated and with a technology called Crossplane. So before I begin, I want to maybe kind of paint a picture of some of the things that I personally see out in the field when I'm working with customers. And this is just kind of the state of, how customers' environments are evolving and becoming a little bit more complex, right? So sometimes we see these environments, they span multiple environments. Sometimes they are on-prem, sometimes they go out into the public cloud, sometimes they're even multi-cloud or maybe even hybrid cloud, right? And as we see these customers move into these more complex environments. Sometimes these environments are restricted by network access. Sometimes we're in air gap scenarios. Sometimes, we want to get away from potentially manually provisioning cloud resources that makes like for a brittle experience. And then we want to get above the value line where we don't necessarily have our customers kind of, provisioning manually cloud resources by hand. It just kind of leads to a brittle experience, gives opportunities for configuration drift and things like that, right? So there's potentially a happy state out there, right? So what if there was a single control plane where you could seamlessly manage both your application installation and then all of this external dependencies? And then what if this was given to you with a declarative API? So you can take advantage of infrastructure as code primitives and kind of prevent that configuration drift that we previously talked about. And then what if it was by default already air gap ready, right? So before we get into the solution, I want to introduce Crossplane at a high level. And you could think of Crossplane as an open source Kubernetes native control plane for managing resources, right? So it's going to give you these primitives called providers. And with these providers, you're going to be able to go out and to connect to cloud environments and provision resources. So we see AWS, we see GCP, we see Azure, but this can extend out to any managed resource as well, right? And so in this picture we see here, this is just one of the abstractions that Crossplane provides. It allows developers to potentially provision high-level resources, and then your maybe platform team or your platform builders can actually go out and create these things called composites, right? So we could think of these composites as potentially like these little blueprints. So at a high level, we give this interface for this blueprint, but there's these other smaller pieces or these atomic pieces that make up this larger blueprint, right? And so this gives like the separation of concerns, and then this gives your developers a smooth API to potentially code against, and then they're not going to actually have to worry about how the underlying resources are configured or even where they're coming from, right? So right now we see this as an AWS RDS instance in a security group, but this could just as easily be from Azure or GCP, right? So now the next piece that I want to talk about is embedded cluster. So you may be familiar with embedded cluster, but it's a lightweight, fully managed Kubernetes distribution built on the K0 distribution. You could think of it as a way to bootstrap with a single command, a virtual machine, or maybe a bare metal machine. And then you're going to be able to kind of get a zero ops Kubernetes experience, right? So the initial day zero installation, the day two operations are all going to be really minimized because we kind of handled that as part of the bootstrapping process, right? So you're going to get a predictable installation base. And like I said, really cut down on, kind of the wrestling that needs to be done to manage Kubernetes. So now let's take a look at our application architecture that we'll be showing you all today. So this is AWS architecture diagram. And so what we wanted to do was actually get a service that was, representative of a cloud environment, right? So you can see this uses S3 buckets. It uses several Lambda functions, uses SQSQ. It uses Amazon Bedrock for some model things that we do against the different models. It uses a persistent storage in Amazon DynamoDB. We have API gateway, and then we have some user authentication, right? Now, there's one thing that we did change out, and this is what I was just previously mentioned about the embedded cluster. So we're no longer actually hosting this application in AWS Amplify, but we're actually hosting the application when we spun up the embedded cluster. And then we're also provisioning our assets from embedded cluster that are out in AWS, right? And I think this kind of cuts back on one of the kind of shortfalls that we see with Crossplane, or maybe not shortfall, but there's this kind of chicken and egg situation with Crossplane where it's this really cool model built into Kubernetes, and then you get that kind of experience where you can not only orchestrate your application, but orchestrate your external cloud resources. But how do you actually get Crossplane up and running, right? And so I think that's where this match really becomes really compelling, because you get this really slick way to spin up your Kubernetes cluster with the embedded cluster. And then from there, you can also spin up your cloud resources from that cluster itself. So now what we'll actually do is actually take a look at some code and jump into some code really quick. Okay. So now the very first thing that we see here, this is our embedded cluster configuration. So it's really straightforward and it's really simple to get started. You just kind of set a version for your embedded cluster. Then there's a KH resource called a configure, or it's a config. And then we actually, in this case, add an extension, right? And so since we're going to be running Crossplane from in the cluster, we want to add the Crossplane Helm repository and the Crossplane Helm chart to our actual embedded cluster installation. And so the reason why we do that is because this typically we think of extensions to the cluster as things that potentially an admin would want to run or kind of be in charge of, or could be cluster-wide access and things like that. So in this case, I might think of things like ingresses, think about things like service meshes, things like that. And so Crossplane kind of fits this bill as something that, our admin team might want to be in charge of kind of doing that initial installation and then making the primitives available for our actual developer teams when they install their application a little bit later. Now, for the application itself, there are four main charts that allow us to actually deploy this application. So they are these compositions, these provider configs, providers, and then the serverless PDF chat is the actual application itself. Now, that sounds like a lot, but I'm gonna go ahead and just kind of demystify that just a little bit. So initially, our provider configs, those are the pieces that actually connect us out to our external environments, right? So that could be potentially on-prem environment, that could be a cloud environment, but ultimately that's going to be your secrets and your configuration data for connecting to that cloud environment. Then our providers are actually what the mechanism within Crossplane that actually does the reconciliation that goes out to create the resources in the public cloud. So once again, this is all driven by Kubernetes, and Crossplane took a lot of its kind of grounding from, thoughts and ideas that came from the Kubernetes ecosystem, right? And so Crossplane, the controllers that they build actually look into the Kubernetes API, and then based on objects that the Crossplane pod creates is going to actually reconcile your cloud state, just by looking at the Kubernetes API, right? And that all happens through these providers. And then finally, there's those compositions. So those compositions are those small pieces that we talked about, those building blocks that we ultimately use to create these larger outcomes and things that we can provision, from our Crossplane environment. And then finally, once again, the serverless PDF chat is just our actual application deployment. So now let's take a look at our deployed application really quick. So we'll see here that we now have our application up and going. We just installed it with the embedded cluster previously, and then I can come in here, and then I can actually upload documents into this system, and then in the back end, the LLM will kind of take over and do a couple things with these documents that I upload. And so we'll just let that run in the background, and then we might have a couple minutes to jump back into that in just a little bit. And now what we're going to do really quick is take a look at our command line, and then we're going to jump to some Kubernetes just to actually see how these resources are kind of being provisioned right now. So the very first thing that I wanted to take a look at is, so this is the embedded cluster installation. So it's really quick, it's really fast within a matter of 3 to 5 minutes, we have our Kubernetes up and running based on a virtual machine-based installation, right? So the next thing that we want to take a look at is we want to take a look at the resources that we actually get provisioned from our Crossplane environment. So the very first thing we'll do here is we'll get our providers. So these are 8 different providers that we're using in the AWS Crossplane deployment. So now just one thing to keep in mind, seems like a lot of providers right there, but AWS kind of splits these providers into they align their providers with each cloud resource, right? So we see a provider for our API gateway, we see a provider for our Cognito, our DynamoDB, S3 Lambda, and a few other things. And then there's also a Kubernetes provider, and we just use that Kubernetes provider just to create a config map to store data that we actually use when we're deploying out our resources into the cloud environment. Now, this next screen is going to be a lot of data because there's a lot of different pieces that we end up deploying out into the cloud. But I'm going to run this command. It's going to be the git manage command. And these are all of the managed resources that Crossplane is handling on our behalf, right? So one of the first things we see up here, it's kind of a little busy here, but we see our DynamoDB, we see a couple of roles and policies, we see some Lambda functions that have been reconciled, we see some permissions, and so then this is what Crossplane is handling in the background for us. And then one of the really interesting things is that through composites, like while we were able to expand this out into, quite a few different resources, it's actually one high-level resource, a composite that we were able to create that kind of manages these sub-resources for us, right? And so with that, the different routes to our different backends and things are actually driven from a higher level composite that we created. So with that, if there's any questions, happy to answer any questions about how you can get going with Replicated on the embedded cluster and Crossplane. But thank you for your time today.